It says continue the activity because I hit start the activity and then blanked. Describe the domain of the function. F of x equals 1 over x, off to the left. I think most students would think that the graph has a domain that covers everything. So it's all real numbers. Let me make sure I have this right. I mean, there's a kid that's immediately gonna know it's every number. They'll probably say number, but every real number except 0. And then if they do ask this, then you'll ask them, why could that be? Or why would that be? And then before every before the class, we probably have to, I don't know how to spell probably. We likely have to review some vocabulary, including domain. Okay. Boop. Students will say, okay, I feel like a lot of students will notice pattern from the back and be like, oh, it's every real number except -1. They might say 1 if they don't pay attention to the negatives. Oh, I guess some students will probably also say the graph does a weird thing here. The graph goes up in different directions here, so that's not part of the domain. You don't get a real value out of that. When you ask them why this is the case, they might either say, they may say, this is what makes the bottom 0. Or some kid might notice that this is a function transformation. Because we're subtracting -1 from x. And then again, they'll also notice that the behavior here is wonky. So it's not, we know it's 1, but like kids will be like, oh, how do you know it's not a little bit less than -1 or a little bit more than -1? So that's why we bring in the algebra. Oop. Yeah, I feel like if you're a kid and you eyeball this, you'll think that this is wider than just one number, the space between this and this, unless you zoom out a lot. Based on the previous two graphs, reproduce to the left and your domain descriptions. What do you notice? Whatever number denominator 0 makes the graph go in different directions. Some students might say infinity. Hey, some might even point out, oh, it's because you're dividing by 0. You divide by smaller and smaller numbers, you get bigger and bigger numbers. So when you divide by 0, it's infinity. But whatever makes the denominator 0 makes the graph go in different directions infinitely. Okay, kid's gonna read this. This makes it easier for them to tell that it's just one number where it blows off, where there isn't a value. Vertical asymptote is a line with respect to a curve, such that the curve approaches the line but does not touch it, even if both the line and the curve are so it's not shown when graphing the function. Okay, cool. Okay. K doesn't move the asymptote, but it does change how far spread out they are. Students will probably zoom. Hopefully they'll realize they have to zoom out, but they might be like, oh, the graph is going away. So maybe keep an eye out for them to not do that. A moves it, and then it flips it. So students will think that that affects the vertical line, the vertical asymptote. B moves it exactly in the direction it needs to go. Whoa. Okay, so if the students experiment a little bit, they'll say, okay, move it to the right, it moves the asymptote to the left that much. But what happens if it's not 1? What happens if it's 2? Then we move it to the left. There's no numbers here. Oh, there we go. They'll zoom in. Oh, it does a half. What if I do 3? I don't know what that number that is. Oh, you can click on it. And then they'll be like, oh, it's 0.3333. I feel like some students will realize that it's 1/3 as a fraction, and they'll... Okay, so what happens if you make it 2? 0.66666. They'll be like, oh, that's 2/3. What happens if we do -1? A half. What do we do? 2. That's 1. 3. 1.5. Some students might not even read the directions, like I just did. Use the slider to change parameter values in the function 2 that 2, 3. Okay, so students will probably think this should be -3. They'll hover over it. Be -1.5. They'll think about it. I feel like some student will realize that it's 3 divided by 2, and then they might check it out. They might be like, okay, what if I make it 6? Will that be 3? And it will be. And then they might be like, oh, what if I make it 3? They'll be like, oh, it's 2. Yes, you can predict the location from given the function rule. Okay. So some kids aren't careful with negatives, and they'll say take B and divide it by A. For these students, you'll have to ask. We'll go back to like, what does that, or what should that do to the denominator? And it should make it 0. 0. Plug it in and check. It won't be 0. So that's what happened. And maybe some students will realize it has to be negative. So you're going to describe to a friend how to find the vertical asymptote of the function rule divided by a, and that's where the vertical asymptote is. Yeah. Get distracted so easily. This is neat. That's very neat. No, they took those extra notes. I really hope you don't mind these notes. You provide to your friend about makes sense. It makes sense because, well, this one won't make sense. Makes sense because I use Desmos and I figured out that that's the pattern. But the goal is to eventually get them to decide. So. You take b and divide it by a. You get a number, take negative b. So with the correction, we'll have negative b. Get a number that when that makes the denominator 0 when you plug it in. I mean, that's a goal. It makes sense because some students are going to say it always works no matter what A and B are. Another student might say I don't know that a student would take it this far, but maybe a student would say it shifts and stretches the function to make the asymptote move. That's probably what they would say. Okay. I guess I should have talked about technology, how they might that's a cop. How they react with technology. I feel like they'll be comfortable with Desmos. Type in your response. Probably review domain. Oh, 2 of them. Yeah, type in your response. Compare the two. Yeah. Read the instructions. Jeez. How can you predict the location of a vertical asymptote given the function rule? Wait, was it? Given the function rule, right? Why are these guys talking about the graph? No, never mind. I'm crazy. Yeah. Okay.